Assalamualaikum and hi everybody. Um, I hope everybody is in good health wherever you are right now. Like the Prime Minister said, stay at home and try to minimize interaction with other people. Keep a social distance and stay healthy. Okay. Um, well, for those who have not known me beforehand, my name is Nurjana Nordin. I am in the team for PLC and automation. I was supposed to take over the subject, I think the week after the semester break, and we actually plan to have automation part thought through that time and to give you some leeway for the project. So we are working on basically trying to simulate the project instead, but we'll talk about that later on. But for now, I will continue a bit. I think this one has been not left out. It's just like Dr. Farid has not have enough time to go through the override instructions. So I will go through with you all. I will try to limit each of the video up to probably 10 to 15 minutes so that it's not going to be too big and it's not going to be too boring for you. I hope that if you have any other questions, please try to either ask here, or I think it's better if you ask in a Telegram group so that you can get faster response from me, okay, later on. So why not we start? Okay, first of all, the part in override instructions actually covers a few functions. Okay, first of all is master code control reset, the jump, subroutine, safety circuitry, and end instructions. Okay, so all of these instructions are basically used to override certain program in your PLC program so that you can do certain functions or certain control irregardless of how many lines that you have in your program. Okay, first of all, we were going to look at the master control reset. Now, the master control reset instructions are basically put in place to execute sections of control logic if certain conditions are met. So basically, if we have these MCR instructions, you will have more flexibility and greater efficiency in program scan. So as we know that in the beginning of the lecture, program scan is basically where the PLC scans a whole program or the whole lines of your program, and the longer lines that you have in your program, it will take longer to execute. So basically, if you have this certain override instructions, you can make it shorter, and therefore the portion of the program not being utilized or not being checked at any time can be jumped over, and output in specific zones in the program can be left in their desired states or otherwise. Okay, so the hardwired MCR is basically in place, okay, first before we have PLC and so on. So basically, if you look at the relay diagram, you can see that let me just try to put some drawing here. Okay, you can see that this is the MCR and also this is the MCR, and you can see that it was drawn on a vertical line, which is basically in a PLC program it's not you cannot actually do this. So on this relay diagram you can see that the MCR contacts here as well as here actually are related to this coil MCR here. So whenever you press the start button for a master control relay, so you will activate this coil MCR here, and therefore all other MCR contacts will be open, which means that you will basically break the circuit. Okay, so in this relay diagram you can see that this start button, okay, push button for a master control reset, is to provide input or output power shutdown of an entire circuit. So unless the MCR coil is energized, there is no power flow to the load side of the MCR contacts. Okay. However, this itself cannot be programmed into PLC. As we know, you cannot actually draw on a vertical line. So in PLC, the way that we do is basically, I need to erase this first. Let me erase this first. Okay, so what we do is basically we have some kind of form depending on the manufacturers. Okay, so there are some instructions. So it is similar to hardwired. So basically, when the instruction is true, the circuit functions normally. When the instruction is false, the output is then switched off. Okay, so the program MCR is basically executed simultaneously with hardwired MCR. So we have a hardwired MCR in place, as well as the software execution of it. Okay, so the MCR instructions are programmed to control what we call a fence zone. So it's like you have a gate at the front and at the end of the program. So it is always used in pairs to enable or disable a zone within a ladder program, and usually it has no address. Okay, so if you program the first MCR with input instructions in the rung, you will have to program the end MCR without any other instructions in the rung. Okay, so basically the MCR becomes your fence for execution of the instruction in between. So in Omron, we use the interlock instructions, which is IL and ILC, to basically do the master control reset. Okay, so it will always need to be used together. So it's like IL is used for the front gate, and then ILC is used for the end gate. So both of them must be written together to block the part of the program that you want to control. Okay, so in Omron, if the execution condition for IL is off, then the interlock section between IL and ILC, which means all the programs in between the gate, will be treated as shown below. And you can see that in the table, we have few instructions posted there. So you have out and out not, which is a typical coil form, and then TIM and TIM H, which is timer and high speed timer, counter and keep, DFU and DIFD, and all other instructions. So basically, if the execution condition is off, for example, the coil will be turned off. Okay, so even if you have execution condition for that coil is on, the output will still be off. Okay, timer will be reset. Okay, so for counter, the present value is maintained. So if you're counting down, for example, from 10 to 9, 10, 9, 8, and so on. So if you have executed the interlock in between, for example, 5 and 4, so whatever it stopped before the interlock execution, the present value will stay there. Okay, even though the counting or the execution for your counter keeps turning on and off. Okay, both DFU and DIFD will not be executed, and for keep, the bit status will be maintained. Okay, all other instructions are not executed, and all memory memory bits, IR, AR, LR, HR, and SR, bits and words written to as operands in the instructions are turned off. Okay, so there is no access to that memory at that time. Now, if you execute IL instruction, the interlock, so basically if your execution condition is on, so whatever that you have written in between the fans will be executed as normal. So basically, for the MCR to work in Omron, you have to make sure that the bit or the contact that are connected to IL must be turned off. Okay, so if you turn off that IL, then you will skip the whole thing. Okay, not only skip, then whatever, even if there are execution in between that lines, we will always have the output to be turned off. Okay, so that will happen in interlock.